Welcome to lesson 15. Today's Friday. This is Friday's lesson since you guys are hopefully in PE and in electives today. Our learning targets are: I can find the lengths of horizontal and vertical line segments in the coordinate plane, and I can plot polygons on the coordinate plane when I have coordinates for the vertices. So these are our targets for today. That's what we're working on. Okay, so for 15.1, it gives us a coordinate plane, and it wants us to draw a figure in the coordinate plane that has at least 3 of the following properties: 6 vertices, 1 pair of parallel sides, at least 1 right angle, and 2 sides the same length. I wrote that in because it got cut off, but yeah, that's another one. So we need to use at least 3 of these. I don't want to do this for you guys in the video because I think that if I show you one that works, it's going to take away from you trying. But I will just explain what each of these criteria mean. So vertices, that's plural for vertex. So a vertex is like where 2 line segments meet. So for example, in a triangle, you have 3 vertices right here, and right here. So your figure needs to have 6 of those. Okay. Then a parallel sides. So you guys probably remember back to geometry, we talked a lot about parallel lines. Lines that are parallel never touch each other. So they look something like this, or like this. They do not look like that, or like this, or what's another example? Like that. No, they have to be non-touching, and they could go on forever not touching. So that's what parallel lines mean. So in a shape, they don't necessarily have to be the same size to be parallel. So for example, hold on. This line and this line are parallel even if they're not the same length. Or in a shape like this, well, those are the same length. Or like in a shape like this line and this line are parallel, and this line and this line are parallel. So they don't have to be the same length to be parallel. Okay, right angle. So remember, a right angle is a 90-degree angle, and it's basically any corner is a 90-degree angle. So any angle along one of these lines in your coordinate graph would get you a right angle. It doesn't matter the direction. Yeah, but any way it faces along an edge of the coordinate plane. Okay. Lastly, 2 sides that are the same length. So how you know if they're the same length is that they're the same amount of squares long. So it could be 3 squares long that way and 3 squares long this way. Both of those sides are 3 squares long, and so they're the same length. Okay. So your job now, and you want to pause the video to do this, is to draw a figure in the coordinate plane with 3 of those properties. If you could do all 4, that would be cool. However many you can do, try for 3. And keep playing around and drawing your shapes in there until you get it. Okay. Once you've done that, unpause the video. I'm going to move on to 15.2. Or, no, question 2, sorry. So it wants to know if your figure is a polygon. A reminder of what a polygon is: it is a 2-dimensional shape. It has at least 3 sides. All the sides are straight, and it is a closed shape. So, for example, a circle is not a polygon. A 3D cube is not a polygon. This shape, that's not a polygon. This shape right here, it's not a polygon. Okay, so it needs to fit all the criteria I just wrote down. So look at your shape and figure out if it does. Is it a polygon? Is it not a polygon? All right, in 15.2, we are given coordinates and we need to plot them. So let's go ahead and look at polygon number 1. I'm going to go ahead and plot that with you guys or for you guys, and then I would like you to plot the rest on your own. Plotting points on a coordinate grid is something that you need to know how to do, and so I would love for you guys to have as much practice doing it as possible. Okay, so remember, x values are side to side, y values are up and down. X always comes first, and then y. Okay, do a different color. Okay, so first we have -7, 4. So I'm going to go over to the left on the x-axis to -7, and then up to +4. Oops. And I'm going to end up right there. All right, now we have -8, 1 over, up to 5. It's going to go right there. Okay, -8 again, 6, right above it. -7, 7, right there. -5, 7. -5, 5, right here. And -7, 4, which we already plotted right there. So our shape is going to look something like this, kind of a weird looking polygon. And before you guys try to plot the rest on your own, I want to remind you of the quadrant names. So here we have quadrant 1. Oh, my Apple, hold on. Apple Pen technical difficulties. Okay, here we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And remember, this to help you when you're plotting. In quadrant 1, you're always going to have a positive x and a positive y. In quadrant 2, we're always going to have a negative x, positive y, which we did in all of our points in this polygon. So that's good. Here we're going to have negative x, negative y. And lastly, in 4, we're going to have positive x, negative y. So make sure that you are plotting the points in the correct quadrant as you go. If you have questions with coordinate graphing, you guys please reach out and set up an individual appointment for me, because it's an important skill to have and we want to get you feeling comfortable and confident in doing so. Okay, I'm going to move on, but please pause this video and finish 15.2 on your own. Alright. 15.3. So this part of the lesson is kind of tricky. It's giving you a route through a maze, and it wants you to figure out what the coordinates are of each point. But we do not have a labeled coordinate grid, and so that is what makes this kind of tricky. So the first question is asking us to figure out what the coordinates of the first 2 and the last 2 points of this route are. So these are the first 2 points. These are the last 2 points. Okay? So that's the first thing we need to do, which is kind of tricky. However, we do have some information. We know that our x value of this point right here is 11, positive 11. And so that helps us to figure out what that value is. We also know that this value over here is -11. So in order to figure out what our scale would be in our coordinate plane, we kind of need to figure out where our x and y axis would go. And so in order to do that, we need to find the halfway point between 11 and -11. If you count the space in between, we have 10 squares, and then a half square and a half square here. And so you can figure out that the halfway point is about right here. I'm going to go ahead and erase this because we don't need that. Okay, so that's our halfway point. The next thing that we need to do is we need to find the halfway point on the other axis. So we know we have positive 15 and negative 15. So if we count these squares, we have a half here and a half here, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and half a half makes 15. Okay, so you can find that your halfway point between those points are right here. Okay, so here I went ahead and I made our y-axis and our x-axis. So this makes it a little bit easier because now we know where our axes are, and so we can more easily figure out the scale and then figure out what our points are. So we know that 11 is right here. Oops. We know that that's 11. And we know that this is negative 11. And so to figure out what our scale is, we have to know how many points we have. So we have 1, 2, 3, 4, 5, and a half. So think about what each point would have to be if we have 5 points and then a half point to get to 11. You can kind of guess what the scale would be. So if each of these purple points I just made went by 1, it would go 1, 2, 3, 4, 5, 11. That doesn't make any sense. If they went by 5s, it would go 5, 10, 15, 20, 25, 11. That doesn't make any sense. So let's try going by 2s. 2, 4, 6, 8, 10, and then this half is half of a square, and so that would make sense to be 11 because this next point would be 12. So it looks like our scale side to side is going by 2s. So that's going to be a huge help for us. Our negative scale is also going to go by 2s. So it's going to go negative 2, negative 4, negative 6, negative 8, negative 10, etc. Okay. So that helps us in the sense that we are trying to find the coordinates of this point. So we now know that the x value for that point is going to be positive 12 because it is right below the positive 12 on our x value. Okay, now we need to figure out what the y value would be for this one. So we need to figure out what our scale is for our y. We know that we have 15 up here and we have negative 15 down here. And so let's count the squares to get there. We have 1, 2, 3, 4, 5, 6. Oops, hold on. 1, 2, 3, 4, 5, 6, 7 and a half. Okay, so we have 7 and a half points between there. So again, we can try it out. If we repeated 1 7 times, we would not get to 15. So let's try 2. 2, 4, 6, 8, 10, 12, 14, 16. So directly in between 16 and 14 would be 15, and that works out perfectly. So it looks like our scale up and down is also by 2s. So then we need to figure out what this point would be right here. So let's count down negative 2, negative 4, negative 6, negative 8. So right here, we're going to have negative 8. Okay, so we know the first point is positive 12, negative 8. Let's look at the second point, which remember is this one right here. I can see that it's in line with the first one as far as its y value. And so because of that, I can automatically put a negative 8 in the same spot as well. Now to figure out what x value it is, we can just go see what that is right there. And we land at positive 4. So our first value is going to be 12, negative 8, and our second value is going to be 4, negative 8. Okay, let's look at our last two, which are over here. Okay, so our second to last is our second to last point is 2 spaces for our x value over, and then if you count up, you can see that it's at positive 8. Okay, now our last point is 1, 2, 3, 4. It's at negative 12. Okay. Oops, I made a mistake. I forgot about our scale. I just counted 2 over. It's not going to be 2 in our x value. It's actually going to be negative 4, because this is negative 2, negative 4, negative 6, negative 8. If that's just a reminder, you guys, that it's always very important to label your axes to make sure you don't make mistakes like I just did very quickly. So here we have negative 4, positive 8. So very similar actually to our point on the other side. Positive 4, negative 8. We have the opposite here. This is our second to last point. And then let's look at our last point. When you go over the x value, you can see that we're at negative 12 here. And so it's going to start with negative 12. And then we are going up to positive 8 as well. So also the opposite of the first. Okay. B asks, how far did he walk from his starting point to his ending point? Okay. Show how you know. So it wants to know the distance between the two. So there's different ways you could go about doing this. So we know, let's see. This is his starting point. I'm going to highlight it. And his ending point is right here. I'm going to just erase all this other stuff I've got going on to not confuse you guys. So his starting point is positive 12, negative 8. And his ending point is negative 12, positive 8. So using that information, you can kind of tell how far he walked. So just looking at the x values, we have 12 steps to the right of 0, and we have 12 steps to the left of 0. So that's a total of 24 steps from here to here. Okay, that's 24 steps left to right, from right to left, from this point to this point. I got that from 12 plus 12. And then up and down from your bottom, from the first to the top, we have 8 steps and 8 steps. And so that's going to be 16 steps from from the bottom to the top, okay? So he walked 24 steps from left to right and then 16 steps up. Okay. I hope that this was helpful. I know that 15.3 is a little bit confusing, and it's especially confusing because my writing is so small and the coordinate grid is so small. But if you need extra help with this lesson and figuring out how to figure out the scale and figuring out the distance between and what the points are, send me a message and I will re-explain it to you or help you out. The other option is online. There is an applet. You can see this is a screenshot of the applet right here, but you can play around with the coordinates and the points on the applet, and that's a really cool way to kind of figure it out. Again, please contact me if you need help, and I hope you guys have a great day. Remember what the learning targets were. I can find the lengths of horizontal and vertical segments, and I can plot polygons on the coordinate plane when I have the coordinates for the vertices. Evaluate how you did,